In this problem, we have a spring that has a stiffness of 200 Newton per meter. So we're talking about this spring, and is unstretched when the 25 kilogram block is at A. So at A right here is unstretched. So we can consider this our zero location. Determine the acceleration of the block when S equals 0.4. So this is S. So the block moved a displacement of 0.4. The contact surface between the block and the plane is smooth. All right, so here we said again, smooth. Smooth means that we are not considering any friction in here. From what we have in this demonstration, as you can see, here we have 0.3. This is where the spring is unstretched at A. And we're told that from A, it moved a distance of 0.4. So the distance from here to here is 0.4 meter. Another word right here. So, and this can form a right triangle. And this is the stretched spring. So we can think of this as a triangle. This is 0.3. This is 0.4. When you take the square root of 0.4, add it to the square root of 0.3, and take the square root, it will give you 0.5. So that tells us that the distance from here to here is 0.5. So how much did the spring stretch? So originally it's at, we said what, 0.3, right? And then stretched, and the new distance is 0.5. So the difference between 0.5 and 0.3, so the displacement is 0.2. All right, so now we will draw the free body diagram of the 25 kilogram block. It's 25, right? Yes, 25. Okay. So the first force we have in here is our 100 Newton force. And here we have the force due to the spring. And we can break this into vertical component and horizontal component. And we say this is the force of the spring. And we can use this angle right here. So here we said that we have this triangle like this. Remember, 0.3, 0.4, 0.5. So if we flip this right here, from 0.4, 0.3, 0.5, and this will be our angle theta. All right, so what we will use this angle theta, which is this angle theta right here. All right, and here obviously we have the mass due to gravity, and we have the normal, but here we will not add the forces in the y direction because there is no movement in the y direction. And there is no friction because here we're told that we have a smooth surface because friction is related to the normal force. So here we will say that the sum of the forces, where this thing will move to the left, the sum of the forces in the x direction equal to mass times acceleration in the x direction. So let's say, so this will be your positive x-axis, this will be your positive y-axis. No, sorry, this is wrong. It will be different. positive x alright. So right here to the right we have our 100 Newton minus the horizontal component, which is this, which is force of the spring, times, since this is adjacent, so it will be 0.4, and the cosine is adjacent over hypotenuse, so 0.4 over 0.5. 0.4 over 0.5 equal to, the mass is 25 kilogram. 25 kilogram. So you can say that 100 minus the force of the spring is what? Is the spring constant times the how much the spring got stretched or compressed, times 0.4 over 0.5 equal to 25 kilogram. So that will be 100 minus K, we said it's 200. The amount that's being stretched, we found it to be the difference between 0.5 and 0.3, which is 0.2, times 0.4 over 0.5 equal to 25 times acceleration, the x direction, the x direction. So that will be what? 100. Let's plug this into our calculator. It will be 200 times 0.240 times 0.4 divided by 0.5 will give us 32 minus 32 equal to 25 AX. 100 over 25 is 4. Correct. Minus 32 divided by 25. Let's just write 32 over 25 equal to acceleration in the x direction, so that will be 4 minus 32 divided by 25, and that will give us that the acceleration in the x direction will be 2.72 meter over second squared. So that will be our answer. And here a quick recall, any problem that you have relating to kinetics, it's always a very good idea to make things clear for you is to always draw your free body diagram and make sure that you understand and you write down what is given, sketch what you need to find, draw your free body diagram properly. If you do that, you can solve your problems, no issue.